Hello, welcome to module 12. So in this module 12, we're going to move on to another level of testing, and we're going to specifically discuss the concept of user interface testing. Okay, so the overview for today is we're going to discuss the basic concept for UI testing, some of the techniques that you can use for doing UI testing, and the last one is I'm going to introduce you some of the tools that can help us to do automated UI testing. So just to recall you a bit, there are different kinds of testing. So unit testing are the tests that written by programmers, and the aim is to look for the errors in the object or in the units of the code. And for integration testing, it's a testing when we want to find the errors when we connect the subsystem together. We haven't talked about integration testing yet, but it will come after in a few next modules. And the last one that we are focusing on today, it is called system testing, which means we're going to test the entire system and we're going to see the whole behavior of a system as a whole. So with this, we're going to test it based on the requirements that we have. So we try to test the software in the same way as the user as much as possible. So for the functional test, we check whether the system meets the functional requirements. And we can also do some performance testing that will answer the non-functional requirements. And the system test can also be used in the later phases of the test called acceptance test or installation test that will be done by the clients. Okay, so just to remind you, we have this so-called V model. That we have the model looks like a V shape. And we have discussed this concept of unit testing already. So for unit testing, we're going to test the code that we have by writing another code to check for the correctness of that unit of code. Today, we're going to discuss this where we're going to do system tests and we're going to check the high-level design of our system to make sure that the whole behavior of the system is correct. So the UI test is a kind of system test. So we test the application from the UI layer down back to the back-end part of the software. So it goes from this direction to the UI, and then it goes back to the logic part again. This is sometimes called end-to-end test. So it goes from one end, which is this front end, to another end, which is the back end, right? So it has a full loop of coming from the back end, showing the result to the front end, and then it goes back to the back end again. This is to ensure that all the layers are working correctly, and it can also integrate their module into the whole system correctly as well. Compared to the integration test or the unit test, it doesn't test the full loop of the system. So for integration test, you would check only this part that you check the back-end logic and their integration to make sure that the connectivity are okay. And the unit test itself, you only check on the code on the back end, and you don't actually check for their integration as well. But the benefit of the unit test is it's fast to run, and it's also very easy to create. So this is a so-called the test pyramid. Okay, the original version is this one by Mike Cohn. So Mike Cohn says that the test should have the larger amount of unit tests at the bottom, okay, which is faster to run, and it has isolation. So which means we test each unit separately, and we don't need to have them integrated. And then the second part of the test that should be the second largest is the service test or the integration test. And the last thing, which is the UI test, supposed to be the most minimal one. So the number of the UI tests should be the smallest compared to integration and compared to the unit test. That is because the UI test is slow and it requires more integration than unit and integration tests. So this is from Google. So Google also follow the test pyramid proposed by Mike Cohn. They give this percentage of the tests that they have at their company. So for Google, they do unit tests 80% of all the number of tests. And they do integration tests 15%. Lastly, they only have 5% left for the end-to-end test for all the products in their company. So you can see that the end-to-end test, although is important, but we don't need so many tests for that because it is slow. It requires a lot of integration and resources to do. So we're supposed to have a better foundation of strong unit tests, and then we have some amount of integration tests, and finally the end-to-end test will be just only a tiny amount at the top. However, many companies, including the companies in Thailand, we still have this problem called the anti-patterns of the test suite. So many companies are relying a lot on manual UI tests. So this is the UI test. And they have just a few amount of automated UI tests and even smaller amount of integration tests and the least smallest amount of the unit tests. This is called the ice cream cone anti-pattern. The companies focus too much on the manual test, and then they focus second on the automated tests of the UI, but they leave the unit test as a smaller part. The other problem is that they also have a large number of unit tests, a large number of end-to-end tests, but they do a small number of integration tests. This is also not optimal. So the optimal part would be a lot of unit tests, some smaller number of integration tests, and only a few amount of end-to-end or the UI tests. Okay. So what are the difference between unit tests that you have known already and the UI tests? The unit tests are all about development. So this is written by programmers. However, for the UI test, it's about verification. We want to make sure that the software works correctly according to the requirements. The unit tests give you a rapid, quick feedback. UI tests can give you quite a slow feedback. Unit test is low level. You go to the code, you check the code level. This is very high level for the UI test because you check the whole system. The unit test is pretty local. We check every function that we have in the code. But this one, we go from end to end, from the UI to the back end. Unit test is cheap, while the UI test is expensive. Unit test is fast, but the UI test is pretty slow. Unit tests can be pretty solid depending on how we write the test, but UI tests can be fragile depending on many factors that might affect the test. And the unit test itself, I'll skip some of them. It's used to develop, while the UI test is used to test. And the last one is the unit test. We test from the developer perspective, while the UI test, we test from the customer point of view. Okay, so you try to simulate the user's actions. All right. And when we do this kind of UI testing, you can select some strategies to do it. So the first one is we can just do ad hoc testing. So we just randomly go to the product and we just click on things. However, we can use a better approach by doing more strategic testing. So we can do UI automation that we can simulate the the usage of the product UI using code. The first one is you can use record playback. So you just record what the user clicks by simulating what the user click in the UI of the system, or you can write the code to kind of simulate those mouse clicks and also keyboard typing. So if we rely on the ad hoc test, you can do pretty simple tests fast, and you don't need so much specialized knowledge on that. However, the drawbacks of this is, since everything is so ad hoc, you don't have any strategic way of doing it. So sometimes it might not be the same every single time that you do the test, and you might need to repeat the test multiple times. You cannot rerun it after you have done it the first time, so you have to go back and manually check it again. So in the end, this might cost more in the later phases in the project timeline. So can we do better? Can we do strategic tests? You can follow the functional testing concept, systematic testing concept that we have learned in the few previous modules, right? So you can apply the concept of input space partitioning to the UI, and then you can select the value to be put in, and then you can think about the scenarios that cover all the branches. When you click this and then you don't click this, when you select this and then you don't select this. So it's best to mix both kind of testing. So you do systematic tests first, and then you left some of them for ad hoc testing, which we sometimes call exploratory testing. All right. So what are the techniques for doing UI testing? The techniques that you can apply for UI tests, this applies over multiple types of user interfaces, like local application, like shown in this figure, web application, or the mobile application as well. So the first one is we try to flush out all the error messages. So you try to make the system to go into the wrong states, and you expect to have this error message. So you can input the value with an empty string, or you can give invalid string. So some string that are too short or too long over the expected size that one might have, you might give some kind of special characters. So with this technique, you can use ISP to find this kind of input combination. You can also give 0 negative numbers in case that the value expected might be a positive number, and some settings that you think it do not make sense. So something that not the happy path that the developer were thinking about or the user usually do. So you try to explore those corner cases and see whether we get these error message or not, or are these error message are correct ones or not. The second one is we can try to create input buffer overflow. So the input buffer overflow is we try to make a very long input over the expected size of the input that the layout of UI can handle. So if we give this pretty long string, for example, into some of the code's name, would the layout changes? Can it handle this kind of so long string? It might break the layout, so that you can find some of the corner cases in the application interface as well. The third one is we try to overflow the data structure. So if the UI contains some page, like multiple pages, or it contains a list, then we try to add the amount of pages or the amount of items in the list, so many, so that it might overflow the data structure that we have. It might cause some crashes to the software, or it might create some weird or awkward appearance on the UI as well. So let's say if we have this kind of list, what about if we populate it until something like 100, 200, 300 items, okay? The next one is we can try to violate some of the app's assumptions. So what would the app perform if we try to modify the file that are being used in the program, and we try to modify it directly during the time that the file is being used? Would the program crashes or not? Or if the network goes down, if we plug out the LAN connection, or if we turn off the Wi-Fi connection suddenly, how would the UI react to that? Does it show the correct error message? Or what if we try to depleted the amount of memory that are available for the machine. Would the UI of the system still handle that? And again, if we try to also use a lot of CPU times, would the app slow down or not? Okay, so this is more about the performance of the system or of the software system. Okay, whether it is slow according to the resources that it has, or it can handle such kind of lower resources accordingly. The next thing that you can try is try to get some repeated or duplicated input. So if we try the same input multiple times, sometimes it can expose bugs for you. So what about you already have an existing user, but we try to add the same user again? Or if we try to create a file that already exists in the program, what would it handle? Or the other way around, if we delete a file that already got deleted, or we try to use the UI to delete something that doesn't exist, or even you try to press a button multiple times. So think about the key buttons that we might have in an online shopping system. When you click buy or you click pay, what if we click it multiple times? Does it charge the user more than one time or not? So this is a good thing that we should test to make sure that our system is reliable. Okay. And if we have a web app, what if we click the back button on the browser? Does the web application handle such states correctly or not? The next one is we can try to cause some invalid outputs. So some of the GUI, it prevents us from giving bad inputs, but we can still try to find some combination that might not be expected, and we can create these kind of invalid outputs. So for example, if we want to check the calendar, and the calendar restrict us to select the February to only have one to the day 1 to day 28. But what if we change the year to a leap year first, and then we change the date to February 29, and then we change the day back into the non-leap year? We might still have these invalid dates of February, and then we try to give that as an input. So this kind of thing, let's see whether we can populate these invalid outputs, and how does it affect the UI of the system. Another thing is, because the UI depends a lot on visualization, so what if we try to move the UI, we try to resize the UI to make it smaller, to make it larger, to make it wider, to make it thinner, so on and so on. And then we see whether some of the elements are missing or not, like the scroll bars, some of the controls, did they disappear, or did the layout and formatting looks weird or not after we try this kind of moving and resizing of the UI. Another one is we can try to enabling and disabling elements. So if we enable, are they doing the same thing that they're supposed to do, to try to toggle between on and off multiple times? Or if you have something that shouldn't be clickable, something that already been disabled, like you have the gray out button, what if we click on it? Should it still be clickable or not? So we can do this kind of double check to make sure that it might not be just only the UI, but the whole button or the whole element is fully disabled. Okay, so next I'm gonna talk about some specific concepts that we can apply for automated web testing. So when we test the web specifically, the web is based on the web technology such as HTML and CSS. So if you think back to the unit testing concept, our test case consists of input value and the expected output. So when we do the test of the UI, how would we provide the input values? We give those values through the UIs. Like you click on things, you type in the search box, you type in the input box. But what should be the expected output? How do we define this expected output? So when we do UI tests, you check the expected output based on the visualization that the UI gives back to you after you have given the input values. And if we have a web application, we can use HTML for doing such assertion similar to the unit testing. So when we write the test, we can assert whether some elements are showing on the screen or not, like the header with the word checkout, does it appear on the web? And we can check whether these number of items are being shown in a p tag on the web or not. So HTML is for you to assert. So we can assert whether this thing appear, this thing is correct based on the content of the page. However, if we want to select some specific things before we do assertion, we need to select them using CSS. So when you have the web, the content will be formatted using HTML, but we have a style that specifies the look and feel of each specific element. And we have different type of CSS component. Can be class, it can be ID. So we can select specific thing based on the class or the ID of the CSS that we have. So we can select elements based on its attribute. And we use these kind of CSS selector to be able to precisely pick on the element that we are interested in. So if possible, when we do web testing, it's best to search using the ID, because by using the ID of that specific element, it is easier to grab. You go specifically to those elements. It is easier to understand, easier to maintain for your test cases as well. So if possible, use CSS based on the ID to query for the element that you want to test. Okay, now comes to the last part of the lecture in this module. So there are some tools that we can use to help us. Instead of doing just manual tests based on the concept that we learn, we can try to do some automated UI testing. So the first tool that we need to mention is called Selenium tool. So Selenium is an open source, it's a free automated testing suite. It is created for web application and it can be used across different browsers and platforms. And testing that is done using Selenium tool usually will be referred to as Selenium testing, okay, or Selenium test. And Selenium has many versions. It has Selenium integrated development environment or Selenium IDE, which runs on the browser as an extension. And you have the WebDriver version. You have the remote control version, which is already deprecated, and the larger version called Selenium Grid. And if you use the Selenium IDE, we can do records and playback. So you try to show Selenium on what you want to do by showing the clicking, the typing, the input, and the navigation. And Selenium IDE will record that, and it can replay back when you want to test your website again. So this is called record and playback testing, okay? So Selenium IDE is the simplest one that I mentioned. It is the plugin on the web browser. So you can apply it to Firefox, you can apply it to Chrome, you can install it just from the marketplace or the App Store on those browsers. However, it can do very limited things. So it can record and play back. But if you want to do some more testing, for example, if you want to do some assertion for some specific elements, you cannot do that. So Selenium IDE is a pretty simple version, but it is not very useful in the real practical sense. The next one is called Selenium WebDriver. So the Selenium WebDriver is a better version than the Selenium IDE, and it involves programming itself to write the script to let Selenium run the test cases that we have. And Selenium WebDriver supports multiple languages like Java, C#, PHP, Python, Perl, Ruby, so on and so on. So the Selenium WebDriver it communicates directly to the browser. So the browser will be controlled by Selenium WebDriver. And then the interaction with the browser seems to be more realistic. So it is like the actual user interactions with the browser. And then it is faster executed than the IDE and the RC version that already discontinued. However, it is more complicated than Selenium IDE, and you need to have programming knowledge in order to do this kind of Selenium WebDriver script writing. It might not support all the browsers that are available, but nowadays we have some more recent tools that you can also use. Okay. So example of the Selenium test is, this is the one written in Java. So you write a test case just like you do unit tests, right? But you have to create a test class that extends Selenium test cases. And then when you do tests, you start a new method. You tell it to do something, open the web, click on something, wait for the page to load, and then you can do this kind of assertion, right? So you can do assert just like when you do unit tests. So this is similar to writing unit tests, but we applied it into the web UI. Okay, and I would like to zoom in a bit here. So we can try to write a script to open some Google web page. We enter some of the query string by searching for this element Q, which is that search box. And then we put the word that we want to put is cheese, right? So you send the key cheese, and then you wait for some time for the result to come back. And then we check whether the result is correct or not. So we get these elements by the class name, and then we check whether the result is correct. The other tool that are widely used is a robot framework. So robot framework is also an open source automation for the UI testing. And it is based on Selenium. So first, when you set up robots, you have to also set up Selenium framework. And the robot framework help us to write the test in a very easy syntax, which is closely to human language, right? So you're not going to write something that looks like programming languages, but you write a script that look like a human instructions. And this robot framework is used by a lot in industry like Cisco, Nokia, and other companies. This is an example of a robot framework syntax, right? So you can see that it is much closer to natural language. So we say valid login. We open the login page. We input the credential with this. And when we submit the credentials, and the welcome page should be open, and then we close the browser. There are also other tools nowadays like Puppeteer, Playwright, or Cypress that you can also try. So the tools itself are improving and evolving over time, but I think the concept stays the same. So that is pretty much it for this module. I discussed the concept of UI testing and the techniques that you can use for doing UI testing. And the last thing is that we discussed some tools that we can use for doing automated UI testing. And that's all for this module. See you in the next module.